else on the graph example? Worksheet 3, we kind of already talked about, kind of already quizzed on. We realized our brains have a tendency to get tricked. But on example 2, on example 3, were there any corrections that you made, or were there any parts of a question that you're like, I'm not sure why they did this? You got to ask it in groups. Okay. We're going to have some other, like, word problem-ish long answer FRQ is kind of what this is, in the sense of it's one beginning piece of information broken down into, in an FRQ, it would be A and B and C, and this would be a number up here. Like, this is problem number 2, for instance, A, B, C. This is very AP-ish in the sense of it's a question with space. They would actually have a bigger space on, like, an answer booklet that you guys fill out. But that explanation, that justification, the using of theorems, etc., showing of work, labeling of units, etc., all super important stuff for us to keep track of. So anyway, I'm not pretending that all of you have a mastery of these 2 examples. We didn't walk through it together, but sometimes in upper div classes, which calculus definitely is, it's pointing towards college, etc., sometimes your teacher isn't going to always go over absolutely everything. So if they ask questions, or if they have office hours, or if they give you an opportunity, you have to be ready. You have to be ready to be like, wait, I need this. You have to be able to advocate for yourself. So anyway, we'll have some more experience in that motion packet, but please, if you're stuck, don't just like write something down and move on. Make sure you get your questions answered. We were working yesterday, and we actually got a lot of good work done. Excellent job, you guys, for period 6. I thought we were going to catch up, and nope. They got to this stage. But they didn't get their examples done, which was super sad. But you guys technically didn't get them done either. What did we do yesterday? We did all 3, but did we get them done? No. What did we do? We set it up, and we're to the point that we could finish if only we, what? What is left to do in every single one of these? And this one, and this one, and this one. Graph it out? Plug it in, substitution. We have to actually use our given function, because right now, I have no clue what this function is. Actually, here's the crazy thing. Right now, I could change the function and you'd still be totally fine. I couldn't change the interval, or we'd get in a little bit of trouble, but I could change the function. The interval is where we got our numbers, so if I change the interval, all that would change. If I change n, all this would change. What if I made n, what if I made n 4? P.S. If you're in period 6 and you're watching this video, catch up, please just pause the video. But we'll go to yesterday's video, even better. By coming back, if I change n equals 4, I'm going to do it just for a second, and I'm going to undo and take everything away. Just think together. You don't even have to write it in your notes. If I change this to n equals 4, what changes? The number of rectangles, which means the number of subintervals. And there would be one of these, right? So I would need another one. The base is not 1. What would the base be, Adam? Because I would be doing 2 minus negative 1 dividing by 4, right? Instead of by 3. So then I would have 3/4 be all of my bases for the first and the second rectangle and the third rectangle and the fourth rectangle. But wait a minute, who would I plug in as the height of my fourth rectangle? Stink. Who would I plug in as my height of my first rectangle? Would it still be negative 1? Oh yeah, because we start at the left, and what's at the far left of my interval? Okay, so that stays the same. Start at the far left, but would it go over a full 1 unit to get to 0 and then plug in 0? No, it would only go how much of a unit? 3/4. So for the next one, question, where would I be for the second rectangle? F of negative 1/4? Do you guys see it? I would need to change this to be, I'm over here now, and I'm at negative 1/4. I went 3/4 of that. And then, wait a minute, how do I go? I'm not going to use that one either, are I? Am I? If I go, I know, sorry, awkward. If I go 3/4 from negative 1/4, where am I now? Oh, because because you're adding 3/4, right? So now I'm at 1/2. And then I go 3/4 from 1/2, or 3/4 from 2/4. Where would I be? 5/4. And then if I go 3/4 from 5/4, where am I? 8/4, which is 2. So then all I have to do is change this guy to be f of, he would still be f of -1. That's fine. He would be f of -1/4. Then I would have f of 1/2, and then I would have f of 5/4. Question, does changing the number of rectangles force us to kind of reevaluate some of our work? But is the pattern the same? Do I still kind of do a number line? I do from the beginning and I do from the end, and I just split up based on whatever splitting I have? Can I go by fractions? Yes. Can I go by decimals? Sure. Can I go by whole numbers? Perfect. I hope so. But I can go by whatever I want, and I don't even necessarily have to draw a picture to be like, oh, hey, he'd go there, and oh, then he'd go there, and then he'd go there. I mean, I could draw it, and if I did draw it, I would end up with one. Oops. Nope, it would be there, sorry. And then I would be here. And I would end up with 1, 2, 3, 4 rectangles, and I'm even closer than I was before. But all of that was if I changed n equals 4. Now, hold on, coming back. What if I change the subinterval instead? So what if n is still equal to 3? Oh, thank goodness, we're going by whole numbers. Oh, we did a lot of work. Whole numbers, so much easier, just going to -1, 0, 1. We're almost there. Whew. What if I change the subinterval instead? And what if I go from -2 to 2? What would change? The base. Everything changes again. Because now I have 2 minus -2, so now I have 4/3. And then I'd have to start at -2. And I'd have to go 4/3 from -2 going to +2. Could I use, no, I can't use any of that. So I'd have to change everything, right? Because I'd have to go, well, now I'm starting over here. So my first rectangle would be f of -2 times 4/3, my new base of a distance of 4 being cut into 3s. Man, this would have been a lot easier if I kept that n equals 4 around, huh? And then going 4/3 from -2, I don't know. Oh, -6/3 plus 4/3 would be -2/3. Anyway, we could go ahead and keep on going to get our approximately 4 different subintervals. Okay, I'm just throwing that at you guys, because you guys got to see all 3 of these examples yesterday, and I'm going to still need to do that in period 6 today. But let's go out and let's go back. Here's what I want you to do in your groups. You just told me, or at least some of your classmates just told me, and I agreed with them, that we basically set up every single one of these, but we didn't solve any of them. I want you to strategically use your graphing calculator. I'm not even going to make you do it by hand. Strategically use your graphing calculator to solve these in the simplest way possible. Ready, set, go. Strategically, you and your groups, I want you to discuss what's the simplest way of finishing the first, finishing, and that should lead you to finishing the second and third. I won't make you do all 3 necessarily distinct. For this first one, if you needed to finish it, what would be the simplest way to use your calculator? The most strategic, the most efficient. Efficiency and strategy is really important on the AP. Way to finish this problem. Go! There are multiple ways. Just get the right answer, but also think what's the most strategic, most efficient way. We're going to see if any other group came up with a simpler way. We'll see if another group found a simpler way. The simplest way to solve this left Riemann sum approximation. The simplest way to solve this left Riemann sum approximation. All right, I'm going to freeze the screen so you guys can't see it, and I'm going to show what I think is the simplest. We'll see if anybody figured out a simpler way. But this is what I think the simplest is.
Oh, I think 4.
Okay, you ready? We'll see. We'll see if my way is simpler than yours. I figured out my function. My function was 9 minus x squared. I'm holding this to stir the creamer in my coffee in case you're wondering why I'm holding it. Anyway, I came over to y equals, and I threw in my function once, because I'm like, oh man, if n was 10, if n was 15, if n was 1,000, I don't want to plug it in 10 different times. Like, no thank you. I'm going to say the function once. I'm going to go back to my home screen, and then, ready? Alpha, trace. The shortest way to find y bars. Because your calculator can do f of.
What?
Now, technically, to be even simpler, I did hear a few of you guys saying, like, it's just going to be times 1, and you're right, but couldn't this, in other examples, be times 3/4 or 4/3 or 2 or 10 or something? So technically, even to make it simpler, I think I would actually throw in, like, hey, let's multiply the base 1, and then let's do alpha trace. There's y1. Of. Oh, the first one's -1. Plus, what's the next one? Alpha.
I put -11.
Oh, that's a bummer. My finger stuttered. But the calculator program did. And then of 0, right? And then, and you guys should be doing this way faster than me even, because I have to like deal with the computer and lag and like a really huge calculator that I'm maneuvering around. Dun 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 dun. Woohoo! Yeah. So what would I change if my function was different? Right here, I just need to put in a different function, and I can find it in any area with n equals 3 between -1 to 2. That's cool. What if it was this exact same function, but I changed the, let's see, the n equals 4? Well, if I change the n equals 4, that's no big deal. All I have to do is steal this. Ooh, the most efficient way to get there. Second, back arrow. Goes all the way to the beginning of the line. That's cool. And then I could do my, hey, I'm splitting 3 into 4 pieces. That's the first thing that we did, and we changed all that work. I would do second, delete, the insert button lets me just put in, hey, now the bases are 3/4. What changed? The -1 stayed the same. What changed? Add 3/4. Oh, that was -1/4. So that'd be second, insert, -0.25. Delete that guy. And then I add 3/4 to that, right? And adding 3/4 to that would have been 1/2, which is point, and then second insert, second delete 5. And then I could go to the very end. Oh, wait a minute, I don't have another one. That's right, because I only had 3. So now I go grab another one, alpha trace y equals. And then I end at 1/2 plus 3/4 was 5/4, which is 1.25. Anyway, do you see how fast I was able to even change it to n equals 4? Or n equals 5, or n equals 10, or n equals 8? Now, there technically is a simpler way to do it, but only if you understand it really well. Did anybody do it any shorter than throwing in the function only one time and using your f of y1 of notation? The approximation. If you're like an integral, you got the exact, but you didn't get the approximate. Isn't there another little dude that can do that addition all at once? But you have to know how to do the summation for it to work. And that's the hard part. Because you would have to figure out, well, I just use the X button because it's the simplest one as far as variables to hit. You would have to start at one rectangle. Let's start with the first one and go to 3 rectangles. You would only have to write y1 first, or one time, because the summation says, sure, at 1, at 2, at 3. But then you have to figure out, what do I put in here such that I get -1, 0, and 1? That's the hard part. In this example, yes, but that won't work for all of them, sadly. Like, meaning it won't work for the next one, right? But it was a good idea. Adam is right. X minus 2 would totally get me -1, 0, and 1 for 1 to 3. A little bit better way of doing it is that you could do -1, which is my starting A. This will always work. Plus, what was my delta X? What was my base? What am I moving by? I'm moving by 1s. Plus 1x. And then I could do my delta, let's see, hold on, don't enter sigma, you're in some trouble. And I could do my times 1. Which you might be like, okay, that was a lot of work for what? Oh, I didn't. I didn't realize I put in that parenthesis. I need the times 1 right here. There we go. y1 of okay, and I just need to do this guy. Okay, so 22. Is that what you guys got when you plugged in the other one? That's the final answer? Wait, did any group actually finish the problem? Or were you just trying to figure out how to type it in? Is it 22? What'd you get? 25?
Oh, yeah.
Oh, I started my sigma at 1. Sorry, that's my bad. I started my sigma at 1, and so -1 plus 1 starts 1 away. That's my bad. That's the right end, not the left end. I would need to do x minus 1. Because you don't start by adding 1. The very first one is the actual endpoint, and then you add 1, then you add 1. It's kind of like with sequences and series, how we did n minus 1. Sorry, 25 is correct. 22 is not the left, but it's the right. However, if I was to change this, and I was to need to go to 4, remember, second all the way back is the most efficient way to go to the very beginning. I could go ahead and still start at 1, the first rectangle, but now I'm going to 4 rectangles. What would change? I'm still starting at -1. Yeah, but instead of going by x minus 1 ones, I'm going x minus 1 3/4. Because that would be the new base. And then my base down here, I'm going by 3/4. So -1, hold on, not yet. Okay, I have my -1, then add 3/4, then add 3/4, then add 3/4, 4 times. I should say 3 times after that. But I also need to change my base to be 3 divided by 4. See how quick that was? So sigma, is it helpful? Yes. Is it really useful on the AP? No. Oh, what? Because they're not going to make this a calculator problem, because lots of people have built programs that your graphing calculator can do that just say, you want a Riemann sum? Which one do you want? Left, right, midpoint? Got it. What function do you have? Got it. What's your n? Got it. And you can just plug it in and not show any work, not do any work, and not do any thinking. And they don't like questions that don't make you think. So here's the problem. Is this cool as far as shortening homework? Yes. But what would you need to do on the AP? You ready? What if you weren't allowed to use that cool tool that you're going to be able to use on homework? Well, here's my advice. Most of these will show up on the long answer FRQ with like an A or a B or a C or something. Probably an A or B. This is an easier one. Here's what my advice would have been as far as if you didn't have your calculator, couldn't use your calculator. It was a non-calculator question. I would have done 9 minus -1 squared plus 9 minus 0 squared plus, okay, I'm running out of room. Let me just move it right down here. I could do that. 9 minus 1 squared. And then what do we do with long answers? Woo! Now, if it was a multiple choice, is that going to be enough for you just to stare at it and know the answer? No, you're going to have to simplify. But for a long answer, all you do is plug into your function, make sure you have your bases with pluses in between, and say dun 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 dun. Cool? Okay, so help me out real fast. Use whatever method you thought was best, whether the y1 of, or whether the sigma, and I want you to find me the areas of the right approximation and the midpoint approximation to finish off. You can dual screen it because just a few of you might not have gotten both of these down yesterday because we did do it pretty fast. But we know that 25 is the first one. Let me go ahead and write that equals real quick just because we did do it with our calculator. And we have enough of us collaborating that if all of us say 25, if we had done this by hand, I would have pretty much trusted it. Well, I would have done it too. But we know that one's 25. Go find me the other two. Using whatever method you like the best. Is it the sigma? See if you can get it right. Is it the y1s? See if you can get it right. And if you don't have a calculator, you can write it the long way, like what I did. And you're like, I would have gotten the long answer right. But then check in with the group number as to how they're doing it and whether you would know how. Do you know where the y1 is? Do you know how to put a function into your y equals? Do you want to learn how to use the sigma? Once again, I just said it's not a huge deal for the AP as far as using the sigma to do these, but man, it can make homework shorter. Your group is quiet. I know you're still getting used to it, but start talking. The longer the group is quiet, the more awkward it is to actually start talking in it. Wow, that teacher lunch coffee is really wrong. Have you checked in? Everybody in the group has the correct answer? I'll say look back one for today. Just because usually you love Kyle, like making sure you know. Look back. Oh, that's the time. So it looks like it. Well, approximately. Let's see what you guys think that is in a second. How hard was it, guys, doing the last one, even though the numbers were kind of messy? How much harder than the other ones? Yeah, right? Like, I mean, okay, 0.5, you might have to do like an insert thing. But otherwise, it's not that big a deal. As long as you had a system that you were using, right? Whether it was a sigma or whether it was the y1s up. Couldn't you just like copy and paste and then throw in other numbers if you needed to? So I'm trying to make it set this homework because it's super like work intensive as far as numerically, or I should say, numerically solving or number crunching. What do you guys get for? We should all be in agreement for this one, for the right approximation. 22? Well, that's weird. It's lower than the other one. Now, it does go out a little bit above, but it goes under a lot. Oh, maybe that makes sense. How about this one? 24 point. Sorry, one more time. That's a 2. All right, do we have a way to plug in Riemann sums to our calculator? Now, remember, n could change. The function could change. Go to your y equals and change it. what you're moving by could change based on intervals changing, right? But the system is the same, especially if you're using those y ones. The system is the same. What do you think is the best approximation, 25, 22, or 24.25? Explain, Adam. Why do you think?
The midpoint is like the average of the left and the right, and so.
Now pause. Is it the actual average? What's 22 plus 25 divided by 2? But explain what you're thinking, because what you're thinking is roughly correct, just we can't say it's the actual average because it's not, and that's important to know for multiple choice questions. If you think it's the average, we'll get in trouble. What's being averaged? Not the areas, not even the y's, the x's. You're not choosing the right or the left. The midpoint is an average. That's how I started out pre-calculus. I don't know about Mr. Che, but it was like, hey, midpoint formula. Sure, you can have it memorized, or just realize you're averaging x's, averaging y's. Add them together, divide by 2. Anyway, who knows? Maybe it stuck, maybe it didn't, but they're just averages. So you're averaging the x's, and as a result, if you're using an x that's in between, aren't you able to do a little over and under action at the exact same time? Which theoretically is somewhat balancing out. Now, is this perfect? I don't know. How can we find out? I heard you say, Adam, how do we know the perfect area? The definite integral from, what are my bounds? Of what function? Did you guys learn how to do this yesterday? No. Ready? Period 6, we didn't do it quite as much like, hey, we're going to infinity. It was more like, hey, guess what? So here, right? Guess what? Are you on the home screen? Yes. Cool. Actually, you have the function in your y equals, yeah? Go to your y equals. You have the function. Can you go to, what's that really cool menu? If you have a function, if you have a graph, you can do stuff with. Second, trace. That's where we can do graph stuff. Second, trace. Do you see anything that looks like an integral? Yes. Hit it. Does it ask for a lower limit? That's -1. Does it ask for an upper limit? That's 2. For those of you who don't have a calculator, here you go. Ready? Didn't I say a second ago that I put in y equals? We could get a graph of it if we wanted to. Ooh, I have a weird window. You can always go to Zoom Standard if anything looks funny and reset. The second trace is where all the cool stuff is. Oh, there's an integral number. Lower limit, -1. Upper limit, 2. Sensitive. That's cool. It shades it. You see the area, and the answer is 24. And man, were we close to 24.25? We could have gotten a lot closer if we'd done 10 rectangles. Which, if we know how to use a sigma, how about 100 rectangles? Wait a minute. I wonder if we could actually be a calculator and solve this without actually knowing how to do a definite integral if we just do enough rectangles. So what if we did this rectangle-y thing from right up above? And let's say, let's use this one. And let's say instead of doing 3, we did 100. What would change? I'm trying to see if we would have enough decimals to have the right answer, even if we had no clue what we were actually doing, as far as how to do an integral. If we just knew it had to do with area, and if we just knew the sigma formula, could we get it? What would change? Are we starting at -1 still? Yes. 100, 3 cut into 100ths. Wouldn't that be like 0.03? Okay, so my bases are now going to be 0.03. Oops, too hard. We're not going by ones now. Now we're going by 0.03. And then our bases are 0.03. Because we're taking a distance of 3, cutting it into hundredths. Let's see, how close is that to 24? If you were to round with 3 decimal places, 100 doesn't cut it. Okay, what if we did 1,000? Because remember, CalcAB, the AP exam needs 3 decimal places, right? So I'm trying to get 0.000 rounded, because then it's like, oh, basically I have the right answer, even though I didn't exactly do it right. So what if I went instead to 1,000? Let's see if 1,000 cuts it. Has anybody already gotten to 1,000? Because you can do it faster than I. You guys know what would happen, right? We just do 0.003. Why is it taking so much time? Silly calculator. Oh, he's a computer. Oh, I'm making it do 1,000 different additions where it has to be plugging in and then simplify. I'm so glad I'm not doing A1 to A1000. That would be super tedious and annoying. Thank you, calculator.
Okay, so basically don't put in 1,000.
What do you end up getting? You're still thinking.
Negative 70.8 thousand. I don't know. Not really sure.
I got 24.004.
Listen,
We're close. What do you think is going to happen when I plug in 10,000? Do you see it? It's going to keep on going. Do you guys know that calculators, when it gives you 24, do you think it actually solved the integral like the by hand way with the antiderivative formulas that you don't exactly know how they work yet to solve for that exact answer? Or do you think a computer programmer just taught it how to approximate with so many degrees of accuracy that you'll never know the difference, that it's actually doing approximations when it gives you answers and not the math? As long as it gives you the answer. Because doesn't a calculator just need so many different decimals? Right? So I just needed 3 for the AP, so I only need to go to 10,000, but it needs a few more. Now, technically, Riemann sum approximations, there are other ways to approximate that you need to know more math to understand how they approximate the definite integral. But a lot of the math that's in your calculator, maybe they're just approximations, but there was so many degrees of accuracy that you'll never know the difference because it matches up with the actual. Now, the actual, I just said that a second ago. The actual, what is the actual? I am not telling you today why. I'm just going to be like Jared, the OChem tutor, and show you how I would solve this problem if I were to see it on an AP. I wouldn't draw it, I wouldn't make rectangles, I wouldn't do a Riemann sum, and areas would not be involved at all in my head as far as solving. Even though I should look at this and remember it is an area under this curve between here and here. I would instead start with, hey, indefinite integral would tell me to find an antiderivative which would look like this. And if you want, just for sake of argument, because you don't know any better yet, we'll put plus c. But then I would say, an antiderivative is not an answer. I need a number, and we already plugged it into our calculator, and we figured out the number is 24. How do we get 24? One subtraction. You can do an infinite addition of Riemann sums that are infinitesimally thin with one subtraction of 2 antiderivatives evaluated at the top bound and the bottom bound. I would plug into -1. I'm not telling you why it works. I'm just saying it's a thing for right now. Hey, what's always going to happen if there's a c there and a c there and it's an infinite addition condensed into one subtraction? Well, c minus b goes away. Which is why technically in definite integrals you'll never see us write that. And then what do we have? Isn't that 18 minus 8/3? And isn't that -9 minus, a -1/3 would be +1/3. Now, be careful you don't kill any seals or else we're going to get in some major trouble. But I have 18 minus -9, which would be 27. And I have -8/3 minus 1/3, which would be minus. Dun, 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 dun. Do antiderivatives apply to what we're doing? Yes. Why? Because the answer to every exact area is a definite integral that's solved with an antiderivative evaluated at the top bound, bottom bound. A single subtraction summarizes this infinite addition. But that's a fundamental theorem of calculus concepts that we do not need to, or we cannot cover today. Oh, what if n equals 10? We did so many what ifs. Let's get rid of that. We did like to 1,000. Okay. Evens, we'll talk about homework questions, etc., tomorrow in section 4.2. I'm going to have you guys go ahead and trapezoids. What? If left is in and right is in and midpoint is better, I wonder if trapezoids are best. Anyway, I'm going to have you guys start taking notes. I'm going to grab up the webcam to peek at the actual pages in homework to see if there's like a hint or a pointing in the right direction, or maybe even a homework question someone's currently stuck because they did amazing work and started last night. If you guys want to, you don't even necessarily need to write down this ABC. Just kind of fill it in so you have it ready, so when you zoom in, you can write down the definite integrals. But section 4.3 says, okay, you kind of got an idea about this area thing and this rectangle approximation thing. 4.3 says, let's tackle this definite interval guide. Now, did I kind of sneak in a few things a little early? Yes. Why? I know, it's more fun that way. But section 4.3 isn't going to be totally new for you guys. Let's just skip maybe like one line here, maybe like 2 lines here, and maybe like one line this side. Okay, I'm going to freeze the screen, and then get up the webcam. And if you guys think about it, period 6, I think we should be able to catch up today. P.S. I heard you guys talk about this little time discrepancy thing between the 2 classes. Let's just say you guys focus a bit more, or at least you have quieter personalities. Number 1. Kyle's gone today. Yeah, that's true. Hi, Kyle. Hope you get feeling better. But also, they kind of come in from lunch. They get really sleepy really fast if they're not talking. So it's like, okay, let's keep talking. And I mean, there is the 5 minutes, but to be honest, yeah, Adam, I agree. I don't think it really makes a huge difference because I'm not necessarily praying. Well, chapel day I was, and I think that got us a little bit behind because I was kind of taking time out with every single class on chapel day. Anyway, how are we doing from all that? We doing okay? Did we at least have some deeper thinking that occurred? In some way, shape, or form? Well, I was just checking in this week. It's been an adventure, I feel. Started with chapel, and then I heard it kind of kept going. Here we go. P.S. I don't think I've officially announced this on the backboard, but, well, sweatshirt prices. I was supposed to pass that around. Sorry, I got distracted by seating charts yesterday. Remind me tomorrow. We'll pass around to get people's orders. Finalize them on Monday, send them in. But Miss Delvo has Algebra 1 students that would love some help, or parents that should be trying to get their kids help, etc. Especially in a 1AB class where they're trying to go fast and just a few of them were not ready. And second semester Algebra 1 is the hardest. You have exponent rules, you have factoring, you have foiling before the factoring and keeping it straight when to multiply, and then just factoring in general, the easy and the hard. And then you're getting into things like completing the square and quadratic formula and things that maybe you're not perfect on, but with just looking at a section, you could like, oh, I got this, let's go. And you've heard me, at least if you've had me for pre-cal, and at least a little bit in calculus, you've heard me reteach these basic algebra things kind of again and again and again when we make mistakes as a class. You've seen me model things like using a whiteboard and giving examples, or like, hey, you can do one, cool, you're not done, try again. Different things that, hey, P.S., talk to Adam, he's been working on all sorts of techniques with his little one. But Algebra 1 kids that would love tutoring. Ms. Delvo has told them, based on my recommendation, that anyone who's just starting tutoring, and if it's for my assignment, my advice is start off free, because then you don't feel the pressure of like, I'm being paid and I might be doing a horrible job. Number 1. And number 2, you also kind of get to like build trust, see if it's a thing that's working out for you and for them. You're doing an assignment, so you're getting those blanks signed off, etc. Whether in Miss Delvo's classroom, or if you do it in here, or if you do it in like Mr. Park's peer tutoring, or if you do it in the library, although Adam has quite a sweet deal up there, but he might be able to be like, hey, so when I'm done, maybe you could. But parents can reach out to you, they can work around practice schedules, etc. And if you fulfill however many blanks you need, you are totally allowed to tell them, okay, all my free tutoring is done, and if they want to start paying you, booyah. Adam, is it nice to get paid? Yeah. He's doing a great job. So, anyway, and this is something that you can keep tutoring math all through college as a little side job, an hour, 2, 3 a week. And if you learn how to tutor Algebra 1, well, hey, why not move to Algebra 2 or pre-cal or even calculus? How many kids struggle in calculus in college and high school? Colleges hire you to be in their math labs to tutor kids in college math? It's a thing. Bridget Marquette, Moore Park College, is getting paid pretty handily, and she's rising the ranks pretty well. And she used to hate math. Barely took calculus. Barely made it through Algebra 2. But now she's rocking it. Anyway, all things to consider. Oh, and another one, I have a girl who's a mission controller at NASA who ironically discovered her love for math when she was a math lab tutor at CSUN, which is kind of cool. She discovered her computer science love with Mr. Moffat, but she was always like, that's not me, I couldn't do that. I want to go and I'm not sure, business or something artsy, I forget. Sweet kid, but then all of a sudden in college she was like, oh, I can do this. And she had fun with it and she kept going. Anyway, fun adventures. Okay, I have the book open. You guys have notes set up. We might not cover a lot, but you realize we're talking about the definite integral, which we've already kind of done a lot. Trapezoids, trapezoids are kind of tricky, kind of hard. Unless you realize trapezoids have their own special area formula, so all you got to do is the same thing we've been doing, just different area formula, basically. You could always look up a trapezoid video if you wanted, but how many of you are actually doing trapezoids tonight? Probably none of you. So let's peek real fast at homework. So what's going on in your homework is, bloop, bloop, I see additions, I see sigmas, and I see rectangles. Does this look kind of like what we did in class? I see sigmas, which I didn't give you a lot of these because we don't have to do a lot of sigmas in calculus. I might have given you a couple, but I see, functions with beginnings and endings and n equals. Oh my goodness, it's like class. I see you figure out how to go from below, maybe coming from the left, or above, coming from the right. They give you some ideas, and I think there's an example too. Then they give you rectangles where you have to set it up, but you get to see things like, oh, hey, they're going by halves. I can do that, and there's a function. So you're really either using a graph or using a function or using an equation in order to set up and solve. Now they do say something like, what is this guy? I think I actually let you skip that. If you were to use our pre-cal I squared, I cubed formulas, which I might be able to show you guys for a little bit just to start off class tomorrow, you could solve using the definition of an integral with limits. Oh, it's still frozen? Bad day. But I think I let you skip the ones that aren't necessary for the AP. So if I say something where it says something like area, and it says something like n, you're using the rectangle process. But sometimes, once again, you get to actually see the rectangles and you're just doing it. Or sometimes you get to see the function like what we did in class. So have your notes handy. YouTube video is nearby if you need it. Or will be, and I'll see you.